So now we're going to get into the tough stuff, the stretches and compressions of functions. This is normally where people start getting a little bit lost because it's easy to shift things up and down and left and right and flip them. That's pretty easy. But now we need to compress and stretch. So remember, compress means to squish something together, and stretching, think about being put on a stretching rack. So if I had a bunch of books on my desk and I push down really hard on them, I'm compressing them. And if you can think about that, it'll be a little easier to make you see how you're making something smaller or squeezed together or stretching something out vertically or horizontally. Pretend you've got a big piece of Play-Doh and you're stretching it up, so it'd be vertically, or stretching it across or squishing it together. So now we're going to talk about the vertical stretches and how it works with the equations. Like, how am I going to know if it's something vertically stretched or compressed? So it says vertical stretches, and again, remind you, this handout is available to you to print out from my PBWiki site, and I give you the link to that, okay? So vertical stretches are written in the form y equals a f at x. So a times the function. That's all this f at x means. Don't get confused with this function notation stuff. The graph is vertically stretched by a factor of a. Now it says it's vertically stretched if a is greater than 1. Greater than 1. So 2 times it, 3 f at x, 4 f at x. Even a negative 4 f at x, because the negative, remember, was just a reflection. So if a is greater than 1, then you stretch the graph vertically. And for y, this didn't print out very well, y equals a times f at x, xy becomes x, comma, ay. In other words, remember I told you if it's outside of the brackets, this is a change to x, this is a change to y. So it's outside, right? It's outside the function. So it affects only the y values. And this says I'm going to multiply my function's y values times an a. If a is between 0 and 1, in other words, that means like a fraction or a decimal value that's between 0 and 1. Fractions can be bigger than 1, I know, but if it says a half, that means you're compressing it. So think about if I had a y value of 4 and I'm going to compress it by a half, it's now going to be 2. So the graph is going to be shorter, right? It doesn't go up as high. We're going to see that when we do some of this work, so don't get too worried about the wording yet. Horizontal stretches are written in this form, y equals f times kx. The graph is vertically compressed by a factor of k. So it says if k is greater than 1, then you compress the graph horizontally. If k is between 0 and 1, then you stretch the graph horizontally. Okay, so that's all backwards, right? It doesn't make any sense. You think it would be bigger, you would be stretching it. But remember what I said about x's? Do you remember? They're weird, right? X's are weird. Look, it says kx. So it says for f equals, or y equals f at kx, xy becomes x divided by k. So in other words, up here, see, we did a times the y, but now we're going to divide by the k. X is divided by the k. So weird, right? It's weird. It's in the brackets. X's are weird. They do strange things. Think of the X-Files movies, the X Factor, anything that's kind of strange. X. So you're going to divide by k, and that's why it's compressed if it's bigger than 1. We'll get into that when we look at some of these fractions down here, okay? Just hang on. When a function is stretched horizontally and stretched vertically, the stretches can be performed in either order to give the same image. So sometimes you'll hear your teacher say to perform the transformations in the correct order. So the correct order means that you have to do anything that involves multiplication or division before you shift up and down. Like those are plus and minuses, right? It's just like BEDMAS rules. You do multiplication before you do addition and subtraction. So let's move on to a little graph here. Shift it up. So it says example 1. The graph of y equals f of x is shown below. Boom, 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 joined together with some lines. So you're going to say, well, this is a function? Sure, it's a function. Look, for every value of x is one value for y. But it's not an equation. It's just a series of 4 dots joined together. You can transform anything. It doesn't have to be a parent function to transform it, although we do a lot of those. But your teacher can give you a series of points and say, I want you to transform this, change its shape. So it says the graph of y equals f of x is shown below. Okay, there it is. On the same set of axes, always read your directions carefully, no matter what you're doing, even if it's not math. Graph y equals 2 f of x and y equals a half f of x. Okay, so the first thing you want to think is, am I affecting the x values or the y values? Now, I told you that if it's outside, it's a y. So this is going to be a y. A change to y, a change to y. Over here, it says on the same set of axes graph, f at 2x and f at a half x. These are inside the bracket, so that's a change to x. So let's write that out here. This is important. Change to y. Remember, see here it is. It's outside. Anything outside is a y change. Inside is an x change because it's in part of this part, right? See, we replaced the x and f at x with 2x and a half x. And these were, we placed the a value that's out here. That's just a 1 in this equation, but now it's 2.5. So the first thing you should do when you're working with a series of points is to write out the coordinates so you can apply the changes, because you got to know what the coordinates are, right? So let's look at this one. It's 1, 2, 3, minus 4, and minus 3. So I'm going to write that point here. Minus 4, minus 3. This one here is minus 2 and 1. I need to know the points so I can transform it. I don't have an equation to work with. I just have points. This is 1 and 3. And this is 4 and minus 1. Okay, so let's change our color here. We're going to perform the first transformation. We'll do this one in blue. I'm going to circle it here. I'm going to do it in blue. So 2 f of x means I have to take all of the y values and multiply them by 2. I'm not changing the x. Not this time. Later on we will, but right now it just says x, f of x. So no change to x, only a change to y. So what's going to happen is any point on my function xy is going to become x and 2 y's. So I'm going to multiply all my y values by 2. So this is going to become minus 4 minus 6. This is going to become minus 2 and 2. This is going to be 1 and 6. And this one's going to be 4 and minus 2. So all I have to do now is find all these little points. So no change to x, so I'm just either going to go up or down from here, right? So here's minus 6, minus 2 and plus 2. That's right here. 1 and 6, 3, 4, 5, 6, right up here. And this one's going to be 4 and minus 2. It's going to be here. So let's get out a ruler so we can make this nice and neat. I'm going to join the dots. This is always the fun part, right? It's fun. Math is fun. Oops. Especially if you have colored pencils. Ooh, yeah, color is good. You can use color on your math tests, I'm sure. Okay, can you see how this has now been stretched by a factor of 2? Every y coordinate is twice as big, either lower or higher, because I've multiplied all of the y values by 2. So now let's do, got a nice orange color here. Let's do the half f of x. So that means this time I'm going to do, x is going to stay the same. So x and y are going to go to, I don't do anything to the x, but I'm going to make the y values half, or dividing by 2, right? That means the same thing. So my original point, I'm going to start with this point here because I'm transforming the original function. Don't start working with these guys. This is the function here. So 4 minus 4 and minus 3 is going to become minus 4 and minus 3 over 2. I divided by 2. Unfortunately, 3 divided by 2 is a fraction. Oh my goodness, how will we deal with that? The original function here was minus 2 and 1. So that's going to go to minus 2 and 1/2. The original function was 1 and 3. It's going to become 1 and 3/2. And the original function here was 4 and minus 1. So that's going to be 4 and minus 1/2. Okay, so all I have to do now is find all these little points on your graph. So we have, oh, this is going to be hard to see. We've got minus 2 and 1/2. So it's going to be right here. Minus 2 and 1/2. And this is minus 4 and minus 3/2. Minus 3/2 is minus 1 and 1/2. Oh, it's kind of squishied up here. So it's going to go from there to there. This point is going to be 1 and 3/2. That's going to be right between 1 and 2, like that. And this one's going to be 4 and minus 1/2. That's right here. I cheated, I didn't use a ruler. Okay, so you can see it's compressed, right? We compressed it by 1/2 because the 1/2 changed all the y values by 1/2, and 2 f of x made them twice as big. So that's what you need to do. This is just a change, a stretch or a compression, vertically, vertical, up and down. Okay, so let's take a look at this one here. We have, oh, now look, it's inside the brackets, so we said it's going to be a change to x. So let's see what happens if we change the x. So it says f at 2x. So my rule, my mapping rule for all my points is that I'm going to have to take the x's and y's, and I'm not changing the y. See, there's no number in front of the f. It's only in the brackets. Inside the brackets, change to x, do the opposite. X's are weird. It says 2 x's. And if you look up here, you can see that the 2 x's means I'm going to divide the x by 2. So I do the opposite of what it looks like. It looks like I should go 2 times the x's. But no. You're going to divide the x by 2, and you're going to leave the y alone. That's the first one. So well, we already have the coordinates over on this side. So let's just use those values so we don't have to write all over this one. So this point, minus 4 minus 6, oh sorry, the original point was minus 4 minus 3. Oh, we better write it out. Minus 4 minus 3 is going to become, we're going to divide the x's by 2, right? X divided by 2. So that's easy. Minus 2, minus 3. So minus 2, and minus 3. So notice how the y, the height of the function hasn't changed, but I've moved from here to here. So I'm compressing. It's a horizontal compression. The second point, I guess we better write them in here. Minus 2 and 1. So minus 2 and 1. So write 3. Minus 2 and 1 is going to become minus 1 and 1. Minus 1 and 1. So you can see how I'm compressing. I'm pushing it in, right? It's going this way. This point, which was 1 and 3, 1 and 3 is going to become 1/2 and 3. I'm dividing my x's by 2. See, x divided by 2, or half of it. 1/2 and 3. The height is still the same, but I've compressed it. And this point out here was 4 and minus 1. 4 and minus 1. I'm dividing the x's by 2. That's going to become 2 and minus 1. 2 and minus 1. And there you go. There's a horizontal compression by a factor of 1/2. Now the second one, it says 1/2 f of x. So the rule for this one is going to be x, oh, I wanted orange, got pink. X and y go to, so now I'm going to grab a piece of paper here just for a second for you to see. So I'm going to do x divided by 1/2. X divided by 1/2. Now, do you know how to divide by 1/2? Yes, you invert and multiply. So that's x times 2/1, which means 2 x's. So I'm going to multiply the x's by 2. When you divide by 1/2, you're multiplying by 2. Does that make sense to you? If I divide by 1/2. So if I had a pie and I divide it by 1/2, I'd end up with 2 pieces. So I have 2x and y. I'm not doing anything to the y values. Do you see that? Nothing to the y values, because see, there's nothing out here. This is all it changed to x. So let's go back and just fix up these. I think we're just going to do this one little part, and then we'll come back to do the other values after. Okay, so let's do 2x and y. So I'm going to take the x values and multiply them by 2. So this was -4. So -4 minus 3 becomes -8 and -3. Notice how the height isn't changing. So this is 4, 5, 6, 7, 8. -8 and -3 right inside that bracket. Oops. Okay, so you see it went from here to here. So that's a horizontal stretch by a factor of 2. We made them twice as wide. The point here, which was -2 and 1, is going to become -4 and 1. -4 and 1. Looks like a big spider. And then we have this point here, which was 1 and 3. So 1 and 3 become 2 and 3. So 1 and 3 becomes 2 and 3. And the last one, we had -4 and 1. That's going to become -8 and 1. -8 and 1. So when you join all that together, you're going to have like this. Goes from here to here. And it goes from here to here. It's not so easy to freehand over such a long distance. And this one way out here. Okay, so you can see, oops, just what happened there. Oh, it was supposed to be -1. That's why. -8 and -1. My eyes failed me. The height wasn't supposed to change. Whoa, Miss Havrot, you made a mistake. Teachers make mistakes too, you know. Okay, get rid of that one. There we go. That looks better. Do you see how the heights are still the same? This height, this one to this one, this one to this one. All the heights are the same. The only thing that's changed is the stretch and compression. So this one here, let's go back just for a little review here. This 2x, this was a horizontal, I'm going to write it in blue because we did it in blue. So this was a horizontal compression. I'm going to say. That's a horizontal compression. This one over here that we did in the orange, this was the horizontal stretch. Horizontal stretch. And again, I remind you that if it has to do with x, it's going to be horizontal because x is going this way, right? This is x on the x-axis. So horizontal left and right. Vertical, that was this one. Vertical outside the brackets affects the y values. See, all the y values changed. The x's didn't, but this one, the x's stayed. The x's moved, but the y's didn't because there was no number in front of the function. that was in the brackets. In the brackets, a change to x, and x's are weird. So if it says 2 times the x, you divide by 2. If it says a half x, you divide by a half, which means multiplying by 2. Okay, this one, y's, y is a normal thing. It's out front, so it's normal. You stretch by a factor of 2. That means you make the y's twice as big. You make the y's half as big. So that's a vertical compression, a vertical stretch, a horizontal compression. Make sure you get this really clear. If you keep reminding yourself that x's are weird, x's are weird, and so am I. No, I'm not. X's are weird. They do it looks backwards, right? It's not intuitive what happens here. It's counterintuitive. So if you keep remembering that x's are weird, you're going to do the opposite of what it says. It looks like times 2, divide by 2. Times a half, divide by half. And when we did the shifts, it looks like if you had x minus 3 in here, you'd say, oh, do I go to the left or the right? And you're going to remember what I told you. X's are weird. So if it says minus 3, you're going to go to the right 3. If it said plus 2, you're going to go to the left 2. But these in front of the x's here, these are stretches and compressions. Hope you got that figured out.